So we left off on number 6. So number 6, the limit as x approaches 0. Plug in 0. Always start there. Always start with just plugging in the value and see what we get. If we get 0 over 0, that means we got work left to be done. If we get something else, then we don't have any work left to be done. Okay? So e to the 3 times 0 minus 1 over 0. 3 times 0 is 0, so e to the 0 minus 1 over 0. Anything to the 0 power is 1. So you get 0 over 0 again. Okay? So if we get 0 over 0, we got work left to be done. L'Hopital's rule says derivative. Find the derivative of the top, find the derivative of the bottom. So we have two terms on top, the yellow and the orange, and then one term on bottom. Okay, so the limit as x approaches 0. Anytime you find derivative of anything e to the power, it always starts with itself. So it's going to repeat itself, e to the 3x. And then you're going to multiply by the derivative of the power. So 3x, the derivative of 3x is just 3. So I'm just going to put it in front. Normally I put it afterwards, but I'm just going to put it in front there. Okay. The derivative of negative 1 is 0. And then the derivative of x on the bottom is just 1. So that's the derivative. So when I plug in 0 again, I get e to the 0 power again. E to the 0 power is just 1. So it's just 3 times 1, which is positive 3. Okay. All right, let's try. Let's do number 7 on the other side. On the next page. Number 7. Do that one. I want you to try that one on your own. Number 7. So you plug in 0 for tangent. So tangent of 0, I believe, is 0. Let me double check. Yeah, tangent of 0 is 0. So it's 2 times 0, which is 0. 5 times 0. Okay. Let's say we haven't seen one like this, but you might. Let's say that tangent, so don't write this down, but let's just say this problem wasn't tangent. It was cosine of 0. Let's say it was cosine of x. Cosine of 0 is 1. So 2 times 1 is 2. Could I use L'Hopital's rule now? No. What would be my answer then? Not undefined, close. Does not exist. Does not exist, yeah. Okay, it would be does not exist. Mm-hmm. Yeah, so we haven't seen, like I said, we haven't seen one like that, but it could happen. Okay, so cosine, not cosine. Let's change it back to what it was before, tangent. So tangent of 0 is 0, so we get 0 over 0. Okay, so derivative time. The limit as x approaches 0. So the 2 is just a coefficient. The derivative of tangent is what? Secant squared. And then the derivative of 5x is just 5. Plug in 2, or plug in 0. So we get 2 times Essentially, this is what secant squared means. It means find the secant of 0. Whatever you get, square it. Whatever you get, square it. So secant of 0, secant is going to be cosine flipped. Cosine of 0 is 1, right? So if I flip 1, it's still 1, right? So secant of 0 is 1. So I get 2 times 1 squared. One squared is just 1, so it's 2 over 5. Okay. All right, let's see. Let's do number 9. Number 10, we kind of did a problem like that. We did a problem earlier with the square root. So let's just do number 9, because number 9 has a negative infinity. Okay, so anytime we have a limit to infinity or negative infinity, there's 3 things we got to look at. Top heavy, bottom heavy, equally distributed, right? So right now we have an exponential. So this one's a little, not a little, since it's negative infinity, right? So what negative infinity means is I'm going to plug in a really, 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 really small number because I'm approaching that way on the number line, right? On the number line, that way is positive, that way is negative. So I'm plugging in a really, 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 really small number. Negative, the biggest number you can think of, right? So when I plug that in, it's going to be negative whatever that number is squared, right? That's a polynomial. X squared is a polynomial. The bottom is exponential. But when I plug in a really, 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 really small number, it's going to be a negative times a negative, right? So it's going to be e to that number. It's not going to be negative anymore. It's going to be positive, right? So now, is it bottom heavy, top heavy, or equally distributed? Bottom heavy, yep. The top is a polynomial on top. The bottom is an exponential. So this is going to be bottom heavy. So if it's bottom heavy, 0. That's where negative, you kind of have to look at it a little differently. Because if I plug in a negative number to the bottom, it's going to make it a positive, right? Because the normal rules for negative exponent are, oh, you have a negative exponent, move it to the top, right? But that won't stay the case because I'm plugging in a negative number. Okay, so those are a little bit different that way. Okay. All right. Okay, so rest of the time I'm going to give you guys to work on your practice. It's got 8 problems on it. I'm going to post the answers on Google Classroom so you can check as you go. I'll do number 10 here. We're not going to do it together, but I'll do it on here just so that if you want to see it on the notes, you can see it there. Okay? So I'll let you guys get to it. Let me make sure it's posted.